Hello, welcome to our next video. This time we're looking at integral exponents. So our outcome is still demonstrating an understanding of powers with integral and rational exponents. Reviewing the exponent rules. Two bases are the same base, different exponents, we add them together. If we're dividing them, we subtract the exponents. If we have a power of a power, we multiply them together. And if we have an exponent applied with multiple bases, it applies to all of them within the bracket and only within the bracket. The ratios are similar. All right, integral exponents. Integral here is the adjective form of integer. So integral exponents are exponents which can be natural number exponents like 3 and 5 and 17, or they could be 0 or negatives. So 0 exponents, the rule is that anything raised to the power 0, which is not 0 itself, is 1. 0 itself can be ambiguous depending on how it shows up. So for any non-zero x, you raise it to the exponent 0, you get 1 as the answer. So why is this true? Remember, if we have a ratio, right, of a to the m divided by a to the n, we subtract the exponents. Well, what happens if they equal each other? What happens if m equals n? What do we do when we have the same exponent? Well, on the one hand, we could say that's m minus m, applying our exponent rule, which is a to the 0. On the other hand, we could say this is a number divided by itself. That's 1. Any number divided by itself is 1, and that is the same as base to a 0 exponent. Negative exponents. They reciprocate. So a negative exponent in the numerator goes to the denominator. Negative in the denominator goes to the numerator. Again, we'll recall that same quotient rule, a to the m over a to the n. What happens if the number in the denominator is bigger? Right? Or, well, yes, the bigger number is in the denominator. Well then, for example, x squared over x to the 5th, two of them cancel. We are left with an x in the denominator. We can also apply our rule. 2 minus 5 is a negative 3. So x to the negative 3 equals 1 over x cubed. We could repeat this as often as we wanted with other integers. 1 over x squared is x to the negative 2. 1 over x to the 5th is x to the 5, or negative 5. It'll work for all of them. Let's work with some examples with these. If we simplify using only positive exponents, that means if the greater exponent is in the denominator, that's where the variable stays. So in this case, that 15 over 75 becomes 1 over 5, hence the negative 1 exponent. 3 minus 4 is negative 1, 7 minus 9 is negative 2, and 6 minus 5 is 1. So all these negative exponents have to flip to the other part of the fraction. In this case, that goes from the numerator to the denominator. If we had a negative in the denominator, it would come up to the numerator. So here we'll simplify this using only positive exponents. We start by multiplying our exponents through, and then we start subtracting. So this is 6 cubed is 216. 3 times 5 is 15. For m, 3 times 2 is 6. For n, 3 times 7 is 21. Similarly, the denominator, we square 4. 9 times 2 is 18. M, which is 3 times 2 is 6. And 5 times 2 is 10. Now, our whole numbers are greater on top than the bottom. So if they don't simplify to a fraction, the top is preferred. M to the 6 is equal. K to the 18 is greater. N to the 21 is greater. So 216 divided by 16 is 27. Our k ends up with a negative 3. 27 over 2. M to the 0, n to the 11. So that negative k comes to the denominator. m to the 0 is 1, we drop it, and then we have n to the 11. All right, exercises. Try this one yourself. Pause now. Take all the time you need. All right, solving this one. It works out to 45 over 4, x cubed, y to the negative 4, or y to the negative 7, sorry, z to the 4. That, in turn, simplifies again because we're using only positive exponents. We can't leave y to the negative 7 lying around. All right, now this one we want to simplify. Similar idea, we apply our exponents through right away. So doing that gives us 144 k to the 12, m to the 16, n to the 4, over 512 k to the 12, m to the 15, n to the 6, or n to the 9. Our whole numbers will reduce. Our k's will cancel completely. We'll have 1m left in the numerator and 5 in the denominator. And k to the 0, that's just 1. All right. In summary, x to the 0 is 1 for every x that's not 0. And a negative exponent moves that value to the other part of the fraction. If you have any questions, any feedback, please leave it in the comments. I will do my best to respond in a timely fashion.